So, like Code Rabbi once said in a keynote years ago, and actually using the workflow component for e-commerce, and e-commerce is all about writing good code. So this is my new talk title, live with it, sorry I lied. This talk assumes little knowledge from you, quite a lot of knowledge from me. So I assume you're a PHP developer, and I assume you have experience with a framework or two. How many in here have used Symfony before? Have anyone already used the workflow component? Perfect crowd, one person. So, this talk is open source. It's the first time I give this talk. And that means that there will be some things that I forgot to mention that you still wonder by the end of the talk, or some things that you think you can contribute to the talk. So, at the end of the session, there will be room for questions and contributions. So keep that in mind. And if you get nothing out of this talk at all, here's a picture of me with a dragon. Hi, I'm Michelle. I'm a color and code addict. So that you don't spend the entire talk wondering about my accent. I'm Swedish, grew up in Sweden. I'm half Danish. I lived in the Netherlands for 6 years, and now in Switzerland since 2014. So it's European. And if I talk too fast, let me know. If anything is unclear, let me know. If you don't understand my talk is useless. So in 2014, I moved to Switzerland to work for this awesome company called Leap. During this time, Leap became self-managed, and everyone still does what they did by then. I'm a programmer. I do mainly Symfony. I've been working on the same project since I started Leap 5 years ago. It's an API for the biggest retailer of Switzerland. So that's a lot of data, and it's a lot of fun. But if you have this huge API that you've been developing for 5 years, you have some kind of things you wish you would have done differently. So then we got another project from the same client. He said, well, we could take this API, build a new API, and I have this brilliant idea. Let's build Uber, but for shopping. So, another API, we could finally build an API from scratch, and that would be fun. We would build the perfect code and think through every architecture decision. So the idea of this order API is that you can order your groceries online, and then you click checkout. Everyone in your postcode gets a push notification that they can pick up your order. So they would have to sign up, and then they pick up your order and they get paid. And basically, you have this circle of people like Uber. It's great. So obviously, with a system like this, there will be challenges. One of the challenges is, how do we keep the orders and the prices up to date? Because it's going to change a lot. One of the specifications was that we can have a promotion system and a promotional code, and anywhere in this system you can enter a promotional code, everything can change. Excuse me. So that's workflow helped with that a lot. And the other challenge, because if you're an API and you're the biggest retailer of Switzerland, you want your consumers to love you. And how do consumers love you? With good error messages and awesome documentation. And that's not as easy as it sounds. Handling cancellation of an order. If someone from support cancels an order, there has to be several things. First of all, the picker, if they have picked up the order, has to be notified that's no longer available. All the push notification messages, we have to pull them back. And the customer as well has to be aware. And with a system like this, for the biggest retailer of Switzerland, there's going to be a lot and 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 a lot of SMS and push notifications. So, challenge accepted. Moving on. We knew that an order would have to have many states. There's the opening order, checking out order, deliver order, assign, pick it order, etc. So we thought we should use a state machine. At this point, I got really, really scared, actually, because first time I heard about state machines was from an old friend of mine whose favorite thing to tell me about was quantum physics. So I thought the state machines was just as difficult as quantum physics, otherwise he would not be that interested in it. It turns out it's not the same as quantum physics. But exactly why? Why do we want to keep track of our states? So knowing where our order is in the system, it just makes sense. And a states machine sounds like something that can keep track of that. So let's do it. So assume a traffic light. You have green, yellow, and red lights. And when the light changes, it transitions. So first from green to yellow, from yellow to red, and then again from red to green. What you see here is that it kind of goes in a circle. Red, green, yellow, red, green, yellow. And how do we change the lights? Usually with traffic light, we have a timer. And when the timer reaches 1, transition. Again for red, when it reaches 1, transition, etc., etc. But when the timer is at 0, transition to the same state. So it's still a transition, but it's to the same state. That's going to be important later on. So this is a state machine for a traffic light. So assume you have 3 bubbles, green, yellow, and blue. And you have 2 transitions. The first transition goes to blue, but if you go to the second transition, it goes to blue and yellow. This is not a state machine. This is a workflow. Because in a state machine, you can only have 1 state. In the second transition here, you have 2 states. So if we transfer this into a state machine, it will look like this. So when we think about state machines and workflows and everything like this, as programmers, we already think in states and workflows. This is nothing new. This is logic. If you think of a user has to log in, you first check, is the user logged in or not? You check the state. You always, all the error handling you do, all the checking you do, all the conditional, you usually just check the state of your application. So that's pretty good to know that this is only about making what you already do in your application explicit instead of implicit, and making those checks in less places. So let's look at the order state machine that we built. So if you have an order, I would like to call this a happy workflow. This is the one with tests, and if everything goes through here, we're pretty happy. So first, an order is created. The user clicks a card, creates an order, boom, state open. Then they update items. So in here, they can remove items, add items, all the things people do when they update items. And they can set delivery address on the order. Then the user checks out and enters their credit card details, and all these things, their account gets validated. All the pickers in the postcode of that delivery address get notified. Now there is a picker to pick up. And in our experience, within 2 minutes, a picker will click and pick up that order. That is pretty cool. So the picker then goes shopping, picks up all the items, and eventually the picker delivers the order. And then the card gets charged for order and the picker gets paid. Happy workflow, 5 states. Open, confirmed, assigned to picker, picked up, and delivered. Now, of course, things are going to happen. Let's say the customer made a mistake and they call support and support cancels the order. Or the order is available for so long but no picker picks it up, then the order is aborted. But we had to think about this cancellation state a little bit more, because when an order is cancelled by support, when an order is cancelled by support, they wanted to know when is it cancelled by support, why, etc. And they didn't care about any other cancellations that we did as programmers for technical reasons. So we created a new state, cancelled by systems. So that's all the states. Open, confirmed, assigned to picker, picked up, delivered, cancelled, cancelled by system, and aborted. Now, if you take these states and you draw lines between them, it kind of looks like a graph. How many people in here are familiar with graph theory? Yeah, cool. So you have nodes, which is the circles, and you have the edges, which is the lines between. And the state machine or workflow is part of graph theory. So if you name all these edges, you have transitions. So here is our complete workflow. From open to cancel order for technical reasons, and then you can transition to aborted, from open to confirmed, from open to cancelled, and from confirmed you can transition assigned to picker, and it's assigned, and then you can pick up, and finally deliver. And you can see here that the deliver state can no longer be cancelled, because how do you cancel a delivered order? That would be really funny. Go to the person's home, get their groceries back. I think that wouldn't be popular. And then what's missing in this workflow, because there wasn't enough room on the slide, is what we actually do the most in our application. We transition from one state to the same state a lot. But the important thing here is that we transition. Because when we transition, that is when we check. Can we transition, and also all the logic that happens after. So again, state machines make business logic explicit. If you have this order API application and you don't have a state machine and you try to explain everything, you will probably still draw something like this to try to explain what happens. Obviously with less colors and more businessy. But a workflow does not tell the entire story, so it only helps you transition, and it helps you know what's going on and block certain areas and make sure you're not in the wrong state. So what happens when we transition and what happens after a transition is completely up to us. So, the workflow component. The workflow component became stable on the exact same date as we got the specifications for the order API. Timing. That was perfect. So we thought we would start using the workflow component. And in our Symfony application, all we had to do, and also if you don't have a Symfony application, you can use it. Composer requires Symfony workflow. And there you have your workflow component that you can use. So again, we already have our state machine and our workflow. So the first thing you need to do is you need to configure that in the workflow component. So this is a lot of config and a lot of YAML. So let's break it down a little bit. First, you have framework, and under that you have all the things you have in Symfony. So for workflows, there's the workflow, and then there's the order workflow, and we can define as many workflows as we want. And we have defined that state, the type is state machine. And then there's the marking store. The marking store is what defines where the state should be marked. So where the state should be stored. We say that it's a single state. It can also be a multiple state application, but then it's a workflow. And the argument is state. So that's where it will look on our model, which is also our doctrine entity. In this case, we made our doctrine entity into our model that we also use for this. So this is all the states. Here in a workflow, states are called places. Open, confirmed, assigned to picker, all of them you saw earlier. And then transitions. I will not list all the transitions because we have so many transitions in my app. That would be boring. So let's take a look at the model. In the model, what we chose to do is take all these states that we have and turn them into constants. Because if we don't do and we have to type the state all the time, we would have typos all over our application. And then an array constant to save all of those when we want to loop through the states. And the same for transitions. And the state property itself we define should be open by default, because when you create an order, it's always open. Honestly, this was annoying, really annoying. I didn't like it. And if I did it today, this is not the way I would have done it. So forget what I just taught you. Gone. And in Symfony, you can define your config in several languages. There's YAML, XML, and PHP. What I would have done is written it in PHP, because then I can also have all the constants in there, and I don't forget anything. We had cases where we forgot to update the array and things like this. So it's better to have it in the workflow itself and to have the workflow defined as PHP. So what makes the workflow component really, really strong is that it has an event dispatcher. You don't have to use it. Without it, you would still get you can't transition from this to that. That's all you would get. But with events, it's really useful. So how many people here used events and events dispatchers in PHP? About half. Does everyone know how events work? Okay. So events, they solve tight coupling. Because if you have, in our case, an order, and you want to send an SMS notification on a certain transition, you would then have to say, in the transition, you would have to, so when you send the SMS notification, you would have to, if you don't use events, include something like an SMS sender. So you include an SMS sender, you say, okay, now I did this, send SMS. But with an event, I fire an event, and whatever someone wants to do with it, it's up to them. So then we need a listener. And in Symfony, it's all managed with the event dispatcher. So the event dispatcher allows components to communicate with each other. And this is another component that you can install. So with events, you have listeners, and it's the listeners that does all the logic, basically. So in our case, we created the order workflow listener. In the beginning, this became a monster class, and I wanted to kill myself. No, sorry, that was the wrong terminology. I wanted to stop doing this and, yeah, make sure you only have the services you need in there. But what you do in there, it's this. So you have a function get subscribed events. Every listener has a function like this. And then you see workflow order guard. So Symfony defines this event from your config. Workflow is the component, and order is the name that you defined, and guard is to validate whether the transition is allowed at all. So in our case, the way we chose to do that is by using our constants. Of course, this can also be a little bit prettier. So we have guards, enter events, entered events, and uncompleted. So this is the guard, and here we have a guard confirmed order, and here's the enter state, enter confirmed, and here's the entered, and uncompleted. So with all of these, it will be an event, it gets dispatched, it sees these, it calls that function that we have defined. So this it will call this uncompleted and do all the logic we have in there. So what the workflow component basically does is that it, by default, does not allow transition changes if you have said from this state to that state, there's no changes allowed. It won't do it. And then you can define your own logic, which I will show you. So with this in mind and how everything works, we solved the challenges that we had with using the workflow component. So keeping the order prices up to date and the entire order. One of the challenges we had is that if you cancel an order, you have to take everything back and you have to recalculate, and it's a mess. Another challenge we had, which we noticed quite late on, but thanks to the workflow component was easy to implement, also had to do with keeping orders and prices up to date. Because let's say today bananas are discounted, I put it in my cart, and tomorrow it's still in my cart, I want to check out, but actually tomorrow bananas are not discounted. So you have to make sure you always keep it up to date. And normally in an application you would have an if statement and you would check banana prices and all this stuff. In our case, this is our uncompleted function. And the thing we want here is we say if the state is not delivered, because then we don't do anything, we update all the prices. And we do all the magic that our order modifier does. Great, cool, everything is up to date. And this is a bit bigger in case you couldn't see that. So the other challenge, this is the favorite thing I like to do in APIs, making our consumers love us. Good error messages and documentation. So in this workflow component by default, you get quite a nice error message when a transition is not allowed from one state to another. And having just that already helps the consumer so much. And the documentation, I could print the workflow, give it to them and say, okay, this is how it works, these are different states, this is when you can check for these things, this is when you can expect those things. Because it was so clearly defined, the documentation was also much easier for us to write. So, it helped us make our consumers love us. Now, handling cancellation of an order was also, actually, it happened automatically. Because the side effect with good architecture and events and updating an order on every transition is that cancelled orders always have the correct prices and correct information, and everything is up to date. Now, the other challenge, the workflow component can only do part for us, but it took a part of this role of handling a large amount of SMS and push notifications. So here we have our uncompleted function again. And here we have the order event service. So we have built an event service, and we tell it in the workflow listener that an event happened. And in there, an event happened. The cool thing there is the type, which is the transition name. So we can, with this, be very flexible and say on this transition, send this push notification, on that transition, send that push notification. And in there, we have a transition to state map with all the transitions that we can handle. And then, which I don't have on my slides, it will go and put a message in a queue. And then we can scale that queue endlessly, and it can handle endlessly amount of push notifications. It's pretty cool. The workflow component didn't help us that much here, but the fact that we could be very, very flexible with our transitions helped us a lot. Now, in conclusion, we already think in states and workflows. It's something that's very natural for us as programmers. And the workflow component, it helps us. And state machines make business logic explicit. Workflow component does so much for us with the events and with the guarding. Actually, the guarding, just by writing a config, is what helps the most. And it helps us writing good code. Code that is decoupled, code that is magic. And yeah, it's cool. I know there's a lot that I missed to say, and I have the application open on my computer, so I can demo some parts for you if you like.